Okay, so before we actually do the altitude, let me do a quick reminder. One of the things we did yesterday was what was called the median. And when we're talking about a triangle and the median of a triangle, what I had you draw in yesterday, what we discussed is this idea that if I have this triangle, the median is the segment that you would draw from any vertex of that triangle. Sorry, that pen is dead. So if I went to any of these vertices of this triangle and I took a segment and drew it to the midway point of the opposite side, this is what we called a median. So we dealt with that yesterday. We also have inside of a triangle what we call an altitude. That is also going to be a line segment that can be drawn from any vertex, just like a median would. You go to the vertex and you're going to draw it from that vertex within a triangle. The difference is we don't want to be drawing it to the middle of the opposite side. We want to go to the opposite side still, but when we do it, we want that segment to be perpendicular to the opposite side. So if you go to this first one here, don't draw in what I'm going to draw in. Let's say we start here. Actually, put a dot right there. I'll have you draw that part of it in. Yes, I did actually. I remember. So don't draw this part in. If I said draw the median in, you're looking for the midpoint. So the midpoint of the opposite side is right about here. You would sketch that in. That's a median, so don't draw that in. I do not draw that in. That's what we did yesterday. If I want an altitude, which is what we're looking for now, we want to take a segment and draw it to the opposite side so that when we hit the opposite side, we're perpendicular to that side. So we're forming a perfect 90-degree angle. So we're eyeballing it a little bit here. We're not pulling out compasses and protractors and all that fun stuff. But in order for me to draw this so that it's a 90-degree angle, I probably need to go right about up here. So kind of where you think it is. Even that, I might not have drawn it quite far enough to the left. But what we're hoping for is that this then is a 90-degree angle. I could put a little square there indicating it's a 90-degree angle. Okay. We can do that from every vertex though. So the one that should be a nice one, go to this vertex. So put a dot on this vertex at the top. And again, a median, so don't draw in this. A median is what we did yesterday. A median would go from here to the middle of that opposite side. That's a median. An altitude means we want to go to this opposite side, but we want it to be perpendicular. So the reason this is a nice one is if we understand this is horizontal, I just want to go straight down with a vertical line so that I'm going to the opposite side. And when I get there, I get this nice 90-degree angle. Those are both altitudes. We have the red one and we have the green one. And then last but not least, I will do this in, let's do blue. We should also have an altitude from here. Do your best. See if you're understanding this. Go to the opposite side in a way that when you get to the opposite side, I could look at that and say, yeah, that looks to be about a 90-degree angle. We want to be perpendicular to the opposite side. So where do you think that would be? All right. And you're eyeballing it a little bit, so long as it's not like the complete opposite side of where I'm going to draw it in. But for me to kind of think this is going to be a 90-degree angle, I'm probably drawing it in somewhere up here to where I think this is a nice 90-degree angle right there. But all three of those we would say are altitudes. All right. All right. So that's this one. So go to the second one. The one that I want you to start with is this guy. So we want to draw an altitude from this point to the opposite side. So if this is my opposite side, to make this a 90-degree angle, probably right in here, if I were to draw in a segment from this vertex, I would get a 90-degree angle somewhere right around here. All right. That looks to be like a nice T if we were to kind of rotate it a little bit. Let's see if I can rotate this. Yeah, so if I kind of rotate this, no, the line doesn't move. Darn it. Okay. What I want you to do next, let's see if we understand what this is doing. Kind of a trick question a little bit. Go to this vertex, put a dot. Why is this not working? and draw a, what is going on here? Altitude from this vertex right here. There we go. So go to this opposite side in a way that when you get to the opposite side, you get a 90-degree angle. And it's so easy that it could be a little bit tricky. Anybody know what I'm alluding to or hinting at here? What do we do when we go to the opposite side so that we get a 90-degree angle? Anybody? Armando? Good. Isn't it this side of the triangle already? So your altitude can actually be the side of the triangle. So to get from this side and be 90 degrees, it's just you're basically just retracing that side of the triangle. When you go to the third and final side, so if I now come over here, same thing should happen. If I need to go from this vertex to the opposite side in a way that's a 90-degree angle, you would basically just follow the base of this triangle, and then that's how you're going to get 90 degrees to that opposite side. Okay. The first one, all three of them were inside the triangle. Here, two of the three were the actual sides of the triangle. When we go to this one, let's start with the nice one first. So go to this dot right here and go 90 degrees to the opposite side. So that should be probably almost in the middle here. So if I just kind of go straight up, that's pretty darn close to a 90-degree angle. The other two are a little sneaky. And then, so let me do this one first. Actually, let me do this one first. I think it's easier to understand. So put your dot up here in the upper right-hand corner. There's a little bit more to this definition. So if we read this again, it's a line segment drawn from any vertex such that it is perpendicular to the opposite side or the extension of the opposite side. And the reason for that is there is no way, if I only can include this as the opposite side, there's no place I could draw this in. Hopefully we understand 90-degree angles. Are any of those red line segments anywhere close to a 90-degree angle? No. So that's impossible. But when we start talking about this idea or the extension of that side, so if I now go to that bottom side and we extend it, so I'm going to extend it in a dotted fashion so we know that it's not actually part of the triangle, but we could extend that. Then I can go ahead and draw in an altitude straight down, and it is now perpendicular to, again, this word right here, the extension of the opposite side. All right, so our altitude may not even be in the triangle. So it could be on the triangle, like these, had a couple that were on it. The first one had all three of them inside of it. Oops. And then this one, we actually have a couple that aren't even inside of it. Okay, but those are altitudes. All right, so keep that in mind. The last thing, perpendicular bisector. Again, these words pretty much spell out what's happening. If we understand the idea of perpendicular, that means 90 degrees. We're going to intersect and form 90 degrees. Not only that, but they also bisect. We did that, I think, 2 days ago, where we cut the angle in half, or the side in half. So this is a line, a ray, or a segment that cuts its side in half, but is also perpendicular to that. So if we read through this, understanding what you're given, this would be read as a line. Now that we have arrows, you can't really see this on my can't make this bigger. All right, so the arrows right here mean this is line AE. So this is alluding to this line right here, AE. And then you're going to see this symbol here. We talked about how that symbol means perpendicular. So the line AE is the perpendicular bisector of BD. So when you see that it is the perpendicular bisector of BD, there are a number of things that we can conclude. One of them is this idea of perpendicular. That means all four of these angles right here have to be 90-degree angles. All right. So the first thing we're going to write is that angle BCA. So from B to C to A. And angle ACD. So this angle over here, ACD. And it's all four angles. So if you're good with naming these angles, we're just naming them all. DCE. And then this bottom left-hand corner is ECB. Angle EC are all, you could put 90 degrees if you want. You could also put their right angles are interchangeable. So I would take any option. What that's taking care of is this idea of perpendicular. The other thing is that it's also bisecting that segment. So the second thing that we are going to write, if this blue line is bisecting BD, what that guarantees us is that the segment from B to C would have to be congruent to the segment from C to D. So we're going to put little tick marks here. That's how we indicate segments are congruent. So you would then say segment BC is congruent to segment CD. All right, that's what a perpendicular bisector does. It not only cuts it in half, but it also intersects in a way that forms a 90-degree angle. All right, from there, the last page here, oh no, there is one more. Oh yeah, this guy. So this one now says, if a point is on the perpendicular bisector of a segment. So if I go back to this problem, this blue line is your perpendicular bisector. So the blue line is our perpendicular bisector. Notice how the point A lies on that blue perpendicular bisector. Okay. So what this theorem starts with is, if a point is on the perpendicular bisector of a segment, which A is, as well as E is, then that point, so A or E, is equidistant. So again, equal distance to the endpoints of that segment that we are perpendicular to. All right, so a lot to kind of weed through here. So I'm going to go back to this graph. What that is simply saying is that here are the endpoints of the segment that we're cutting in half. That just means A is equidistant from those two endpoints. So if this is 5, then this must be 5. That's what that means. Notice how E is also on that. So if I go from E to the endpoint D and then to the other endpoint B, then if this is 7, then this would also have to be 7, as long as it lies on that perpendicular bisector. Okay, so that's what that theorem is talking about. All right, and then the last thing, angle bisector, that's pretty straightforward. If I give you an angle, so this draw in, so draw in an angle, and we'll make these two rays. So here's our angle right here. And let's say we'll make a nice angle here. Let's say that this is an 80-degree angle. Again, just kind of understanding language, understand what this is going to do. We want to bisect that angle. So if that angle is 80 degrees and we want to cut that thing in half, we're going to draw in a ray that cuts this thing straight in half. So wherever you think directly in the middle of this is, you're going to sketch in a ray directly in the middle so that that 80-degree angle has now instead become two 40-degree angles. All right, so nothing crazy there. It kind of tells you what's happening. We're bisecting the angle. All right, that's what an angle bisector does. Okay. The rest of this page then now is let's put all of these theorems together. Keep all of this stuff straight, answer some questions. All right, so example number 7. Again, making sure we understand how to read this. This is a ray. Can we see this up there? Yeah, make this a little bigger. So ray KO. So that alludes to this guy right here. That's the ray, starts at K and goes through O. Bisects the angle J, K, M. So that big blue angle is getting cut in half by that yellow ray. All right, that's what that first statement is telling you. I then tell you that the measure of the angle drawn from J to K to M, so J to K to M, this full blue angle is 58 degrees. So real quick, this is hopefully nice. Tell me what the measure of OKM would have to be. All right, Armando, what do you got? Good. So OKM is this angle right here. This would have to be 29 degrees. What would I don't ask you this, but what would this angle here have to be? Good. The yellow ray is cutting the big blue one in half. So if the full thing is 58 and this cuts it in half, each of those has to be 29 degrees. And that's all this was asking you for, was the measure of one of those angles. Okay. So that's an angle bisector. It just cuts the angle right in half. All right, here's some algebra one now. So what we try to do is just make sure we understand it with some numbers, and then we're going to add some algebra to this. So example 8, similar. The measure of angle RAI. So from here to here to here, you were told that that angle has a measure of 3x minus a 5. Next thing you were told is that the angle that goes from I to A to N, so for me, the yellow angle, has a measure of x plus 27. The question, or then you're told that the segment A, or the ray AI, bisects this big angle. All right, so this here is cutting these in half. So similar to what we just said above when Armando did this, if this ray cuts these angles in half, don't these two things have to be equivalent to each other? They have to be equal. So instead of saying 29 and 29 actual numbers, this angle here and this angle here have to be the same. They have to have the same degree measure. So with that understanding, then those have to be equal. So we're going to be able to take those two algebra expressions now, the 3x minus 5. We know those have to be equivalent to each other. So we're just setting up an equation where we're setting them equal. All right, we should be very good at solving equations again by the end of this module, because all of these require us to do a little bit of solving, these little multi-steppers here, variables on both sides. So we're going to subtract that x over, add your 5 over. So 2x is equal to 32. Divide. X is 16. See if that's the answer. Okay, is that the answer we're looking for? No, we need that, but we're ultimately looking for this right here. So we're looking for RAI. So the measure of angle RAI, you were told right here, is 3 times x minus a 5. So I'm just going to do 3 times that x value minus 5. So the measure of angle RAI then is 48 minus a 5, which is 43 degrees. All right. All right. What you're going to see in a lot of these problems coming up, I guess this one has a picture, but a lot of these don't have pictures as we kind of go through them. So I'm going to strongly suggest you want to sketch these out. All right. So if there isn't a diagram for you, diagrams are really nice to mark, to see. We want to sketch these. So we want to understand the notations. This is saying a segment drawn from E to H. So we want to draw that in. So draw in a segment that starts at E and ends at H. Segments do not have arrows. They have a distinct starting point and a distinct ending point. So there's no arrows there. The first one has to be E. The last one has to be H. I'm going to make this one the E. I'm going to make this one an H. That segment is then going to get divided by 2 points, a point F and a point G, in a ratio of 5, 3, 2 from left to right. So what that initially just means is somewhere there's a point over here with F. Somewhere in here there's a point with G that's dividing the segment up. We didn't necessarily know where to draw these in, except I am telling you then now that it's going to be this ratio, 5 to 3 to 2. Starting from left and then ending at right. And what we know is that full length from E to H, this whole thing is a 30. So it's similar to a little angle problem we did yesterday. I think Ella kind of went through that with us. Notice how we now have, highlight them. We have one interval, we have two intervals, and then we have this third interval. And we just so happen to have three numbers that kind of correspond to what that means. So what this simply means is we don't know what these values are, but the first one is going to be 5 times whatever the others are, or whatever the x value is. The second one is going to be 3 times that. And the third one is going to be 2 times that. All right. Set up an equation, because this now hopefully is one you can look at and be like, yeah, this is an easy equation to come up with. Like, how can we set up an equation and then solve that? Joe. Good. All of those added up. So the yellow, blue, and purple. So the 5x, the 3x, and the 2x all added up. Those have to equal the overall amount, which is a 30. And then we're going to solve this. We go ahead and divide. All right, thanks, man. It's the same notes from yesterday. X is a 3. Not your answer, but we obviously needed that. One of the things I want you to find is the length of FG. So FG is this blue interval in here, the one that is 3 times x. So FG, I'm going to do 3 times 3. So we know that is 9. So that's one of our answers. I also want you to name the midpoint. So the second answer would be us saying that the midpoint is what of these guys? All right. So it just a different way of saying you need to find all these values. So don't we now know that this blue area, we just found this to be 9. If I did the purple area twice x, that's 2 times 3. So that's going to be 6. If I wanted the yellow area, that would be 5 times that 3, which is going to be 15. Now we could draw it a little bit more accurately. So don't let this deceive you. We didn't necessarily know how to draw it initially. Which point has the same amount of units to the left as it does to the right? Armando? F. Because here's F. Notice how we have 15 units to the left. We have 15 units to the right. So if we were to redraw this, then we would know for sure that F should be right in the middle. Okay. All right. Do 10. Yeah, we got a little time to burn here. Go all the way through number 10. We've only got 2 left. See if you can answer that one. And if that's quick, because if you're understanding this, this is a very quick one. Feel free to try that last one before we prompt you through it. Okay, so all these equations that we're setting up, that we can set up these equations, usually one of two things. We're taking 2 things we are given and adding them up and setting it equal to something else, or we're setting the 2 guys equal. When you look at this one, it's not C. If that is the case, this is directly, well, let's say this ended up being 10 here, here, 1, here, here. like this one up here, it was similar. And there will be problems where maybe I give you this whole length. And then you could have the levels that equal like that whole length. But all right, not bad. All right. If you got, the X to be 11 and you went through it and you're working on 11, number 11, just continue on 11, see if you can do it. And if you weren't sure about this guy, we'll walk through it right now. So when you read through this and it tells you that C is the midpoint of AB, if C is the midpoint, doesn't that mean that this segment here and this segment here, don't those have to have the same length? They're congruent to each other. So if this is our midpoint, what that tells us is the length of this segment here would have to be equivalent to the length of this segment here. So if we understand that, that then is your thought process in terms of setting up this equation. Those have to be equivalent to each other. All right, so that's where we get this equation from. When we work our way through here and solve this, we want to subtract the 2x over. So 1 is equal to 1x minus a 4. Add the 4 over, and hopefully we got that x to be a 5. Then the question's asking you for the actual lengths of AC, CB, and AB. So from A to C, if I take the 5 and plug it in right here, 2 times 5 is 10, plus the 1 is 11. So the length of AC is 11. You can plug this in if you want over here, but what does this one also then have to spit out? Yeah, it better be 11 because these should be congruent, and it would. So if you did plug it in, that's totally fine. But we would also just know right away that better be 11. And then the overall length from A to B is just those guys added together. So that length would be 22. Okay? So that was good. A lot of people had that. All right, now, number 11. First, we got to be able to draw this. I would definitely encourage you to draw this out. So when we draw this out, so I'm going to draw in a line from L to K. So, and it's going to be a perpendicular bisector to the segment TN. You could really draw any of them first. I'm actually going to draw the segment in first. So I'm going to draw in the segment T to N. So no arrows because there's no arrows on the top of this. That's a segment. You still can't see those notations. There. So there's no arrows up here, so that's a segment. When you look on your paper, I still don't see it on the board here, but there is now, it's just so thin. There is a little arrow above this for LK. So you're now going to draw in a line from L to K that is perpendicular to this line segment and also cuts it right in half. Do that for me before I do it. See if we can do that before I do it. So draw in a line that is now perpendicular to this and cuts it right in half. All right, crossing my fingers. Hopefully we understand if we're cutting it right in half, we should be going through right around here. And if we're going to be perpendicular, largely this is a horizontal line as best I could draw it. So we want to be drawing in a line that would be vertical and is cutting that thing right in half. This would have 2 arrows on the end of it because that's the notation we used. And then we would have a point L and a point K somewhere on that line so that we know it's LK. We go through there forever. All right, did we draw that in, hopefully? Okay, then, second sentence. The intersection of that line and segment is point F. So this intersection right here, you're going to call that point F. Then you are told that the length of the segment drawn from T to F is 3. So that's this right here from T to F. That's going to be 3. Let me write it underneath, not right on top. And then you're asked your questions. All right. If we drew that nicely and we understand that that is a perpendicular bisector, then when I ask you what the length of segment TN, that should be very quick and simple. So see if you could work your way through that. All right. So write down what you think the length of TN would be. All right. What do we think? What would T to N be, Assad? Good. That would have to be 6. Why, Assad?
Because half of TN, which is the absence 3, so the other half has to be 3.
Good. If that is bisecting that segment, then that means this segment here, the one I have highlighted in yellow, and the one that I'm now going to highlight in blue, those have to be equivalent to each other. So when I tell you that this is 3, that means this one over here is also 3. The question is then asking you for the full length of the segment from T to N, so it's just those 2 3s added up. So we're going to get a 6. All right, and then again, if we understand what this is setting up, the next question should also be nice. Find the angle that would be drawn from L to F to N. The first question dealt with the idea that we were bisecting this segment. This next question is understanding that we are also perpendicular to that segment. So the only thing or only degree measure that could possibly be Jada is what? Good. Those would have to be 90-degree angles. It's the whole definition of a perpendicular bisector. Okay. All right. So a lot there. I do want you to do some problems on these tonight. See if we can keep all of this straight. So you do have homework tonight. We'll grab it tomorrow. What's that? I don't. You know, I'll investigate a little bit more. I assumed it didn't. I haven't made a look at it. So I guess I would want 5 or 10 minutes of looking before I have to write it all out. Yeah.